Okay, question 3. In the diagram of circle Z, line AB is tangent to circle Z at point B. Segment ZB is the radius drawn to the point of tangency. Point X is on line AB, and segment ZX is drawn in. So we have the point B, which is on our line, which is the tangent point. We have the radius ZB, and we have point X on our line AB, and we have this, it's not a radius because X isn't on the outside of our circle Z, so it's just the segment ZX drawn in. So Corey must prove that line AB is perpendicular to segment ZB. Which answer choices will be useful for his proof? There is more than one correct answer choice. Select all correct answer choices. Okay, so this is giving us a diagram. It wants to know that a line at its point of tangency is perpendicular to the radius. So I'm actually going to go to the theorems about tangent lines section. And right here it says if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So this looks similar to our diagram. The only thing that would be missing is we had this line to some other point X. That is talking about what we are trying to prove. We're trying to prove that it's perpendicular. So here's this example, prove the theorem. I'm going to click the show all because it'll expand all of those, and I'm going to be looking for that proof example, especially the last part because it has all of the steps. So notice they drew in this line CE, and so they give a paragraph proof on this. So I'm going to scan through the paragraph proof, and I'm going to have a document open, and I'm going to title this reasons for proving a line tangent to a circle, and the radius at the point of tangency is perpendicular. So pretty much this, we were given this, we want to prove this. Maybe that's what I would copy in actually, see if it would copy. It doesn't really copy very well because the lines don't really go over the head of the segment. So anyways, that's what we're given, what we want. So I'm just scanning through this. So this proof can be completed by using a proof by contradiction. So it's going to be proof by contradiction. So I'm copying that. So 1, proof by contradiction. 2, in a proof by contradiction, you'll assume that you're trying to prove is false and show that the assumption contradicts the given information. So we will assume that AB is not perpendicular. So we're going to assume that they're not perpendicular, and that means that some other point on this line would be perpendicular. So I'm just copying that. And I'm just keeping in mind that these are the lines. I might actually just screenshot this, I'm not sure. Recall that the shortest distance from a point to a line is the length of the perpendicular segment between them. That seems like it's pretty valuable information. And so then they're comparing segments, showing one's less than the other one, and showing that point E would have to be interior, and then that is the contradiction that segment AB is not perpendicular to segment CD, which is false. So that is kind of the gist of that paragraph proof. and that's what I would be using to answer this question as a resource. So if we jump back down to this question right here, so we want to prove that this line that's tangent to it is perpendicular to its radius. So there's more than one correct answer choice. So on this, we started off with proof by contradiction, so I'm looking for the contradiction, a contradiction that shows a temporary assumption that segment ZB is not perpendicular to segment. No, because we're going to say yes, because that's the assume that AB is not perpendicular to CD. So if we go back to our example, remember that this was point C. So yes, that is one. The other one that we would be looking for is we want a contradiction that shows that no other segment can be drawn containing a point on AB in such a way that it is perpendicular to segment ZB. I'm getting that from this. The shortest distance from a point to a line is the length of the perpendicular segment between them. And from what I'm remembering in the proof above, that if it wasn't perpendicular, then this point actually ended up being inside right here. So then that would make this not perpendicular. It would make it acute. So I'm just remembering that from the proof. So again, like I said, write down the proof. Find key information, copy it so that you can find the similarities between what it is asking in the other examples. And there was one more. They said to construct another point X on line AB in such a way that ZX is perpendicular to AB. So I'm looking like this and looking at reason 2. It says this means that there is a different point E on line AB where AB would be perpendicular to CE. So it's saying to construct another point. And again, I'm just remembering this. Maybe a good thing to do would be to actually duplicate this tab, pull it over, and make sure you're showing all, and just have the proof open that you found is similar. So again, we found that this one is similar to the question, and that way you can check back and forth with the proof that it's saying. So this one says if contradiction happens, we are going to do it by a contradiction, and then you can actually see the pictures and how it's similar to yours. So again, like I said, right here, this is point C, which is similar to our point Z. So anywhere in here that I saw a C, I would just, in my mind, replace it with a Z. And so I could just draw that similarity from this proof that is given and laid out in the lesson to this proof that I'm using here. That's how I would use the lessons examples to help me with this.